Welcome, welcome, welcome to Python Dictionaries from the Python Made Easy series based on Python 3.7. Boy, are we going to have fun. In this class, we'll look at an intro and an overview to Python dictionaries, how to create them, how to use them, what to use them for. We'll have plenty of examples. We'll change and add to our dictionaries. We will solve problems using dictionaries, and then we'll get into more advanced topics. Once we get to the advanced topics, don't become frustrated. Take a look, glean, see what's possible with Python dictionaries and alternatives. But if it's frustrating for you, you can stop right there and you can go to other classes that will fill in the gaps for some of these terms and some of these things that we're talking about. In the advanced topics, we'll be looking at objects from the Python collections module. These are alternatives to dictionaries, things like default dictionaries and ordered dictionaries. We'll use dictionaries with set operations, and finally we'll use dictionaries in conjunction with things like the zip and max methods. We're going to have a bundle of fun. Let's not waste any more time. Here we go. What are Python dictionaries? Python dictionaries are unordered collections that are stored and fetched by keys instead of by position, and position with something like a list, with the list object or data type. Python dictionaries take the place of records and search tables in other programming languages. The main properties of dictionaries are sometimes called hash tables or associative arrays. They associate a value with a key. For instance, name, which would be the key, and Lucy, which would be the value. Items are not kept in any particular order in dictionaries. They are mutable, so they can grow and shrink in place. Each key may have just one associated value. However, the value could be a collection of objects. They are the only built-in type of the mapping category in the Python language. Internally, dicts, as they are sometimes known, are implemented as hash tables, data tables that support very fast indexing. Let's take a look at dictionaries at work. So here we create a dictionary called dict1 with two key value pairs separated by a colon. We then execute the dictionary. We fetch the value by passing the key for the value we want. So in this case, we want to fetch the value for Fred. So we execute dict1 Fred in square brackets and quotes, and we get back its value coonhound. A second way to create a dictionary is to use the dict method. So here we have my_dict equals dict, and then in parentheses we pass the name equals Lucy, occupation equals comic, and hair equals red. When we execute the myDict variable, we get back all of those key value pairs. A third way to create a dictionary is from two lists using the zip method. So here we have list 1, list 2. Then we create a value called comp_dict equals dict. We feed that the zip method, and then in its parentheses, we feed that list 1 and list 2 respectively. And you see when we execute compdict, they are concatenated together. So they're taken in as a key and a value from across both of those lists. A fourth way to create a dictionary is through dictionary comprehension. So we have numbers_dict equals key colon value for key value in zip, and two lists, 1, 2, and 3, comma, 4, 5, and 6. So when we do this, we see this is a very easy way to automatically create this dictionary of numbers. But of all these types that we've spoken about, let's try to get underneath which one is most efficient, because there will probably become a time when this is important to you. So we use the timeit module, the Python built-in timeit module. So we import timeit, and first we test through Python Interactive. We test three different ways: dict comprehension, a conventional dictionary creation, and then using the dictionary method. So we see that the one that takes the longest by far is dictionary comprehension. The one that takes the least amount of time is the conventional dictionary creation. Now we can do the same, but from the command line instead of from Python Interactive. And the results are the same. The most efficient way to create a dictionary is the conventional way, by using the curly brackets. If you are interested in a great article that goes into why this is, look up Doug Hellman, the performance impact of using dict instead of the dict method instead of the curly brackets in CPython 2.7, just like I have it here. We can get a dictionary's length by using the length or len method. Len, pass it dict1, and we see 2. So that means we have 2 pairs, 2 key value pairs in dict1. We can create a list from dictionary keys. We use the list method. We pass it dict1.keys, and we get Fred and Rosie. Those are the keys. We can do the same with the values. Instead of .keys, we use .values, and we get Coonhound and Chihuahua, respectively. We could create a list from dictionary items, that is both keys and values, by using dict1.items against the list method. And you see we get tuples inside a list. So Fred and Coonhound, Rosie and Chihuahua inside a list. Let's see how we would change a dictionary. In the first example, we'll change the value for key Rosie and we'll make it a list. So here we have dict1, Rosie, Rosie's the key, and now we'll pass an entire list of objects. So now when we execute dict1, we have Fred Coonhound, which stayed unchanged, and then we have Rosie as the key. The value is female, short coat, ferocious, and watch your ankles, which is absolutely true if you knew Rosie. Now we can add a key value pair. Dict1 Ellie equals beautiful girl yellow lab. That string will be the value. Now Ellie as a key doesn't exist, so it will create that for us. Dict1, we have Fred Coonhound, Rosie female, short coat, ferocious, watch your ankles, and Ellie with a string as its value, beautiful girl yellow lab. Now we can delete an entry using the del keyword, del dict1, and we pass Fred as the key. So now when we execute dict1, we see Fred Coonhound is no longer there. We can pop an element by key name, so dict1.pop, and pass it Rosie as our key. And you see now Rosie is no longer there. We only have Ellie, beautiful girl, yellow lab left. We can append the value yellow to a list within an existing dictionary. So dict7, we have 113344, and then my list 12344 4000. So we do dict7 my list.append yellow in quotes within the parentheses, and we get dict7. That last element is my list 1234 4000, and we add the string yellow to that list. So what attributes and methods are available to us when we use a dictionary data type? So if we fire off the dir method against our dict1 dictionary, we will see a bunch of objects coming back. The first thing I'd like to say is, you see this output from the dir where attributes have this leading and trailing double underscore, right? Like in underscore underscore class underscore underscore, or underscore underscore contains underscore underscore. These are known as magic methods or dunders. Dunder stands for double underscores. They enable us to emulate some built-in methods when built-in methods are not supported, for instance, for an empty class. But we can still make use of them. So if you look here at the check membership by key, dict1, again, is the name of our dictionary, dot underscore underscore contains underscore underscore. We pass it Fred. So we're saying, hey, do you contain an element with a key by the name of Fred? And it says false. No, that's not in there, because we know that we popped that. But dict1 dot underscore underscore contains underscore underscore Ellie, do you have that? It comes back true. So we can test for membership. The next example, check for equality between two dictionaries. Dict2 equals dict1. Then dict2 dot underscore underscore EQ, which stands for equals underscore underscore dict1. Yes, they're the same. They better be. I just made it that way. Clear full contents of a dictionary. So we have dict4, and we can simply do dict4 dot clear. And when we execute on dict4, we see that it's empty. Now, to the right-hand side, we create two new dictionaries here. Then we can try some of these other methods. All right, so first we have dict3 underscore underscore GT underscore underscore dict4, and GT stands for greater than. Now what you'll see here with some of these, it comes back as not implemented. So they haven't quite been implemented yet. But if we do an EQ, which is equals, it comes back false. If we do a repr and a string, let's explain these because you'll see these throughout your Python career. REPR or STR. The repr is a built-in function to compute the official string representation of an object. And string is quite the same, except it prints out in a slightly more pleasing representation. So when you're going for aesthetics, you'll want to use string. When you just want the official representation, you can use repr. Then finally, we have dict4.length. So we'll see the length. And length for a dictionary is how many of those key value pairs we have. And in this case, dict4 would have 5. In the example directly below that, we can make a shallow copy of a dictionary. This creates just a reference. These two objects would remain two different objects, and we can test that using the ID method if we wanted to. We don't do it here, but we could. Dict4 is an empty dictionary. Dict4 equals copy dict3. Now dict4 takes on the properties of dict3. So it is 1, 1, 2, 2, 3, 3, 4, 4. Then we can determine if a key exists in a dictionary. Dict7.get, pass it my list, and it tells us, okay, for my list, for the key my list, the values are 1, 2, 3, 4, 4,000, and yellow. You probably remember that from the slide just before. Now we test for a key that's not there. What happens the first time we do this? Dict7.get moo. Nothing. It just returns a new line. It doesn't tell us anything. So if we wanted to implement something that was a bit more valuable to us, we can do dict7.get moo, test for moo, but if moo fails, the second argument here is we can pass in a string like I did that says, hey, it doesn't exist. So now when I do dict7.get moo, comma, does not exist, that's what returns. It says I can't find it. So what is your second value there? Ah, she wants me to bring back does not exist, and that's what happens. All right, so let's solve some problems using dictionaries. Objective number 1, we want to sum all values in the following dictionary. So we have dict1, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 5 pairs. We set our counter to 0, and then we have a for loop value in dict1.values, and then we increase our counter and we print it out. So we create a variable called count of data type integer and set it to 0. It is this that we will use to add up each value in our dictionary. We create our for loop that we will use to loop over each of the values in our dictionary, and when we do, each time we will add the individual value to that of our count integer. So finally, outside of the loop, we're going to print out the value of count after having added each value to it, and we get, just as we would expect, 15. To the right-hand side, objective number 2, take the following dictionary and print out only those words that end in vowels. So how will we solve this? So here, we first create our dictionary and we call it dict2. We then create a list with each vowel from the English dictionary or the English language, A, E, I, O, U. We create a for loop in which we iterate over each value in our dictionary. So for V and dict2.values. Inside our for loop, we create a conditional statement in the form of an if block. We then make use of indexing by using V minus 1. The question we're asking through our if statement is this: if the last letter of each of our values, right, because we're using that minus 1 and in indexing, that's the very last letter of a string, as we iterate through each of them through our for loop, is in our list of vowels, then print it to the screen. If not, pass on it. And you see when we execute this snippet of code, we get exactly what we would expect: pizza, opera, menu. All those strings that end in a vowel. And our last objective before we get to some more of the advanced topics having to do with dictionaries and mappings. We're going to take the following dictionary of 4 mappings, and if the value is uppercase, we're going to add it to our upper list. If it's lower, we'll add it to our lower list. So how do we solve? We create our dictionary and we call it dict1. We then create our 2 empty lists, one to capture the uppercase words and the other to capture the lowercase words, and we name them upper underscore list and lower underscore list respectively. We then create our for loop to iterate over the mappings in our dictionary. This time, instead of using the values method, we're going to use the items method. And we have 2 iterators this time. One represents keys, that's K, and the other represents values, and that's the V. We then use an if statement to test if the value of each key is uppercase using the is upper method. If it is, we append that one to our upper list. If it's not, we append it to our lower list. We then print out both lists. So what do we get? Here's our output. These are the uppercase words, 1 and 3. These are the lowercase words, 2 and 4. So it works exactly as designed. Hot dog, let's get into some more advanced topics. Our first advanced topic is to talk about defaultDict. DefaultDict is the dictionary subclass or child class that calls a factory function to supply missing values. It's from the collections module from this Python standard library, which implements specialized containers, and it acts as an alternative to things like dictionaries, lists, sets, and tuples. The syntax is very straight ahead. DefaultDict, and then in parentheses, we pass it what's known as a default factory. It returns a new dictionary-like object. DefaultDict is a subclass of the built-in dict class, so it has at its disposal all of the same functions that you would have from a regular dictionary. The first argument provides the initial value of this default factory attribute. Its default is to none. All remaining arguments are treated the same as if they were passed to a regular dictionary constructor, including keyword arguments. If a key is not found in the dictionary, then instead of a key error being thrown, as is the case with a regular dictionary, a new entry is created. The type of this new entry is given by the argument that is passed via the DefaultDict, via the default factory. So let's compare how a regular dictionary behaves versus this DefaultDict object. So the first thing we have to do is import it. So from collections, import DefaultDict. With a regular dictionary, we will create an empty dict. my_dict_1 equals open and close curly brackets. So then we call key Santa. It throws an error because, of course, our dictionary is empty. Key error Santa. Now, if we create a default dict here and we pass the default factory to be a string, then when we call and look for key Santa, which clearly doesn't exist because we haven't created anything there yet either, what it does, instead of failing, it adds Santa as a key with a value of none. You see the empty quote strings there. Second example using DefaultDict, I wanted to show you what it's like to use its second optional argument to pass in a dictionary. So again, from collections import star, we create a variable called quargs. We set up a dictionary. Now for our DefaultDict, we call it my_d_int equals DefaultDict int, which is our default factory, this time instead of string, and then we have ** quargs. Then we print my_d_int, and here we may use the same methods that a regular dictionary makes use of. We said that before, and here it is in action. So we create a for loop for k and v in my_d_int_items, print v, so the value, every value as we iterate through the loop, times 2. So 1 is the first value, so 1 becomes 2. The second value, 10, becomes 20, 25 becomes 50, and 100 becomes 200. And in this example, we create a list of tuples. Note how some of the keys are the same. So we have A and 1, B and 2, A and 3, A and 4. So some of these, what will become keys, are duplicated. Then here we create a DefaultDict with a default factory of type list this time. So we've used string, then we've used integer, and now we're using list as our default factory. In our loop, we append our list of tuples to our DefaultDict entitled DD. So you see how our DefaultDict combines all values that align to the same key. Note, A has 3 different integers aligned to it in the form of a list. So its value, A's value, is a list, including the elements 1, 3, and 4, or the integers 1, 3, and 4. Now let's come up with a slightly more advanced or involved example. We're going to populate the DefaultDict with the elements of a user-defined list. So off to the right, I have what happens during each of the iterations. So we're going to step through this line by line by line to really make it completely unambiguous. When an integer is used as a default factory, it will always return 0 by default. That is something that we want to establish right off the bat. Okay, so what happens? We have a function that I've called default underscore val. The two parameters that it takes is list1 and n. So we start with our caller down at the bottom. The value for list1 is x, which is a list with 3 numbers in it, 1, 2, and 3. The value for n equals 2. So we start, results is empty. Our list is empty at this point. Counts, which is our default dict, is also empty. I is 1, right? Because it's going to evaluate the very first element in our list, which is 1. If I is 1, count I does not exist. So what happens when an element doesn't exist and it's presented a default dict? It creates it. Now when it creates it, again, the default factory is an int, so its value will be 0 by default. So since count I is 0, it's less than 2, right? Less than n, which is 2. So I is 1, that gets appended to results, and now counts for the variable 1 is 0 plus 5. So now the value for counts 1 is 5. Okay? Now we go through our second iteration where results now is 1, counts is 1 and 5, I is 2 in our for loop. If I is 2, count I does not exist, right? There's no key labeled 2. So it creates it with a default value of 0, just like before. Since count I is 0, it's less than n, which is 2. Now I is 2, that gets appended to results. And counts 2, its second position, is 0 plus 5 equals 5 again. So now, as we go through our third iteration, results is now 1 and 2. Our list has 1 and 2 in it. Counts is 1, 5, 2, 5. I now is 3. So I is 3, count I does not exist, right? It evaluates that against the default dict. So it says, okay, I'll create it with a value of 0. Since count I is 0, it's less than 2. I is now 3, that gets appended to results. And counts 3, the key value 3, the key 3 is 0 plus 5. So at this point, counts is now 1 colon 5, 2 colon 5, and 3 colon 5. Results is now 1, 2, and 3. And that's supported through the output that we see here to the left. And now we'll talk about the OrderedDict. This is also from the collections container data types from Python. It is a dict subclass that remembers the order in which key entries were added or inserted. It returns an instance of a dictionary subclass supporting the usual dictionary methods. It has at its disposal the move to end method. This moves a key by default to the end of an ordered dictionary, or if we use the last equals false setting, it will do just the opposite and move it to the very beginning. It also supports reversed iterations using the reversed method. Now, when you are testing for equality between two OrderedDict objects, know that they are order sensitive. So if the order is not identical in both, it will not evaluate to true. However, between the OrderedDict and any other mapping object, they are order insensitive. And in that case, it would just function like a plain old dictionary. How does OrderedDict keep its order? Behind the scenes, it maintains a linked list that orders keys according to insertion order. Note then, since these links are maintained in this fashion, the OrderedDict can be greater than 2 times the size of a conventional dictionary. There's a lot going on there. So be aware of this as you scope the requirements for a given application. So let's see the OrderedDict in action. Again, from collections, import OrderedDict. We're going to start with a regular unsorted dictionary. We call it seasons. The first thing we're going to try to do is use an OrderedDict to sort by dictionary key. So we have order by key equals OrderedDict sorted seasons dot items. Key equals lambda s colon s0. And when we use the 0 on an iterator for a dictionary, we know that that will mean the key, because usually the key comes first. Key, value, key, value. So there, when we print it out, first we print the type to satisfy our curiosity, and it's collections.OrderedDict. So then when we print out the ordered underscore by underscore key, which is our OrderedDict, we see on the right hand side with the yellow thumbtack that it comes out fall, spring, summer, winter. So it's not by value, it's by key, alphabetical order in this case, right? F comes before S, SP comes before SU, and then winter is last. Okay, so the next example will sort by dictionary value, right? Same sort of thing here, only when we do the lambda, we have S1, right? So it's the iterator 1 now will be the value instead of the key. So we see here is what we would expect now by the numbers associated with the dictionary. 1, 2, 3, 4, winter, spring, summer, and fall, just like the Carole King song. Next, we'll use the OrderedDict to sort by the length of the key. So how many characters each key has. You see the output here is fall, spring, winter, summer. Right? Fall has 4 characters, spring has 5, but it starts with an S, then winter, then summer has the most characters. Next, we'll sort by dictionary value in reverse. So this is like our dictionary value a few up, but instead we'll do this in the reverse. So we would imagine this would be the exact opposite. We're back to S, our iterator 1, which of course stands for our value, and then we use the reverse equals true key. And what do we have here? We have fall, summer, spring, winter. All right, so exactly in the reverse. So instead of 1, 2, 3, 4, it's 4, 3, 2, 1. Note, when new keys are added, the keys are appended to the end and the sort is not maintained. So it's not like it takes it in and then automatically reshuffles. So we'll see that in the example with the red thumbtack. So we add new season to order by value underscore rev equals 5. And when we look at the output there, we have the same ordering, summer, spring, winter, fall, summer, spring, winter, and then tacked onto the end, new season 5. Okay? On the contrary, sorting dictionaries maintain their sort order when entries are deleted or popped. So here we're going to pop winter, and what do we have? Fall, summer, spring, new season. So it keeps exactly the same order it had previously. So what might an ordered dict be useful for? An ordered dict can be useful for building a mapping that you would use to encode into a different format, like JSON, for example. In this way, you could control the order of fields in your JSON encoding. Let's look at the example below. We would import JSON, and then we would have a dictionary with earth, fire, wind, ether, and water with corresponding digits. Then we would print json.dumps dict1, and we see that we will maintain that order no matter what we do. It's going to print out like that. For those of you who are not familiar, JSON is JavaScript object notation. It's a lightweight data interchange format. It's easy for humans to read and to write, and it's easy for machines to parse and generate. It's taken the place of XML. Let's explore some other things we can do with our Python dictionaries. Our objective here is to find what elements 2 different dictionaries have in common. We do this by performing common set operations by using the keys or items methods. So we have 2 dictionaries, D1 and D2 respectively. We're all about foods here. In fact, we're all about desserts. D1 has apple and pie, fudge and brownies, carrot and cake, Milky and Way, yum and yum. D2 is almost the same. It has apple and crumble, vanilla and brownies, carrot and cake, Milky and Way, yum and yum. So let's go through these examples. First, we want to know what keys are in common. So to do that, we create a variable, keys underscore com equals d1.keys and d2.keys. We print that out, and we see the ones that it has in common by using the AND operator is yum, milky, carrot, and apple. These are just the keys now. Next, we want to know what items, both keys and values, are in common. So we do this with the in underscore common variable. We let that equal d1.items this time and d2.items. We print that out, and we see carrot cake, Milky Way, yum yum. So far, so good. Now we want to know what keys are in D1 but not D2. This we do with our variable only underscore D1. We equal that equals d1.keys minus d2.keys, and we see the only key that is in D1 but not D2 is fudge. Now what keys are in D2 but not D1? It's very similar. We see that that's vanilla, and you can check this against the list. Make sure that I'm being accurate here. This next one should say what items are in D2 but not D1. So the comment here is wrong, so it should say what items are in D2 but not D1. So this is pears in D2 only. So vanilla and brownies and apple and crumble are the only two that are in D2 but not D1. And next, what keys are unique to each set but not in both? And this should say what pairs are unique to each set but not in both. Sorry about that. So this is apple crumble, vanilla brownies, fudge brownies, and apple pie. Those are the ones that are unique to each. And this is our last example of this series. We want to find the maximum age of people stored in a dictionary. So we have ages of all wonderful people who have passed. We have a variable max age equals max, which is the max method. Inside of that, we have the zip method, and we pass it ages.values, ages.keys. When we print the max age, we see that we get James Dean, who in fact would be 87 this year, 2018. Now, there's one thing I'd like to point out that's pretty straight ahead, but it's also pretty useful. Be sure when you do this, you put your values first. Notice we put ages.values and then ages.keys. If you put ages.keys and then ages.value, you will not get the answer you want. Notice we get back Princess Di, right, at 57, which is not correct. So make sure you have values first and then keys. Okay, friends, thank you so much for your participation. We have a lot of other stuff to cover and a lot of other great modules. I encourage you to check them out. Ask any questions. If anything was unclear or if you think I made any mistakes, please call them out, or you want to see something else. You only help me get better, and maybe I can help you in turn. Thank you so much.